Welcome to this explainer. Today, we're taking some incredibly complex construction procedures and breaking them down into clear, easy-to-follow steps. Specifically, we're diving into Chapter 3.2, the erection of rotating equipment. Now, this is literally one of the most demanding and critical operations you will ever see on a plant site. We're talking about a phase where millions of dollars of precision engineering finally arrive on site. And honestly, the stakes for getting it perfectly right, they are astronomically high.
So let's just dive right into it. Why is this so nerve-wracking? Well, when you look around a construction site, you see massive loads being hoisted in the air all the time, right? But rotating equipment is a whole different beast. Unlike those giant, stationary steel storage tanks that can honestly take a little bit of rugged treatment, if you drop a high-speed rotating machine, even a single millimeter too hard, the results can be catastrophic. A sudden, jarring impact can permanently bend its internal shaft or just completely obliterate the sensitive bearings inside. To put it simply for those new to this, these machines might look like massive, indestructible blocks of steel, but they are actually as fragile as delicate glasswork.
Okay, so the absolute core concept we need to grasp here is what the word erection actually means out in the field. It is definitely not just dropping a heavy shipping box into the dirt. Think of it more like moving a multi-ton, highly sensitive grand piano. You have to lift it and place it onto a very specific concrete foundation without a single bump, jolt, or millimeter of error. This procedure is the crucial bridge between logistics, just getting the pump to the site, and actual precision engineering, where it officially becomes a permanent working part of the plant.
Now, you might be surprised to learn that this highly precise physical process actually starts on paper. This happens way before anyone even thinks about touching a rigging strap. You absolutely have to go through a strict pre-lifting checklist. It's basically your ultimate safeguard. First, you verify the total erection weight against the absolute latest drawings. Why? Because sometimes a tiny attached accessory gets added at the last minute and throws the whole weight off. Next, you've got to confirm the crane can actually handle that specific load at the required distance. And finally, you have to pinpoint the exact center of gravity, or C.O.G.
What's really fascinating about that center of gravity is that it isn't just some abstract math equation. The vendor actually paints or physically marks this exact balance point directly onto the equipment itself. It's a critical physical indicator telling the rigging crew exactly where to attach their sling belts. If they do it right, the massive machine won't tip, swing, or flip while it's hanging midair. Beginners often overlook this little painted mark, but let me tell you, missing the C.O.G. by just a few inches, that leads to an unbalanced load and a terrifying tip-over the second the crane takes the weight.
Because a lot of source manuals kind of blur the lines between different construction procedures, we really need to call out a major difference in lifting strategies here. With stationary equipment, say a big pressure vessel, you lift it directly using these heavy welded lugs right on its main body. But rotating equipment like pumps, completely different story. You absolutely must lift them using the thick structural base plate down at the bottom. The actual pump casing on top is simply not designed to handle the stress of a multi-ton lift. If you lift from the wrong spot, you'll literally warp the casing and crush those delicate internal components we talked about earlier.
And that brings us right to a golden rule universally emphasized across the industry. Now, this might seem obvious to a seasoned veteran, but out in the messy reality of the field, it happens. Wrapping a sling belt around a convenient nozzle or, heaven forbid, the rotating shaft itself just to stabilize a load, that is literally the fastest way to destroy the equipment before it even touches the foundation. Applying any lifting force to that shaft ruins the internal seals and permanently bends the rotor. It is a strict, absolute no way, never during rotating equipment erection. So after calculating a perfectly safe lifting path, securing the rigging exactly to the base plate, and getting the whole thing airborne, we reach the high-tension landing phase. This is where everyone holds their breath. The crane operator has to lower this multi-ton piece of equipment incredibly slowly. Meanwhile, the ground crew is manually guiding the suspended load, trying to perfectly align these pre-drilled holes in the base plate with threaded anchor bolts that are sticking straight up out of the concrete foundation. It's like threading a needle, but the thread weighs 5 tons. It requires absolutely seamless communication.
As the base plate finally touches down over those anchor bolts, you'd think the hard part is over, right? Well, the heavy lifting is done, but the micro adjustments are literally just beginning. Workers slide these incredibly thin metal pieces, called shim plates, underneath the base plate to achieve a rough level against the uneven concrete. Then, using these things called jack bolts, they start making microscopic, millimeter-perfect horizontal adjustments. A crane is simply way too jerky for this level of detail. So these jack bolts essentially allow a human being with a hand tool to push a multi-ton machine sideways by fractions of a millimeter. It's really cool.
Okay, the crane is officially detached. Erection complete, time for a coffee break, right? Actually, scratch that. The team immediately pulls out their checklists. They cannot just walk away.
They instantly verify if the anchor bolt projection length is correct, basically making sure there are enough threads sticking out to attach the heavy nuts later. Then, they confirm the equipment's orientation is flawless, because if it's backwards, the piping won't connect properly down the line. And finally, they double-check that the rough leveling they just did with those shim plates is properly set across the entire base plate.
So, we've successfully navigated the entire complex erection phase. The pump is bolted down, it's roughly leveled, and most importantly, it hasn't been damaged. But remember, this highly orchestrated lift merely provides the basic structural platform for the real precision engineering work that comes next: shaft alignment. Think about it. Just how exact do the pump and motor axes need to be perfectly aligned before you can safely hit that power switch without tearing the machine apart? Well, that is a fascinating puzzle we'll be solving next time. Thanks so much for joining this explainer.